Hi, everybody. My name is Julia. I'm a DevRel at EVM, and I'm here to show you how you can bring Solana's liquidity and user base to your EVM dApp without changing a single line of your Solidity code, without adding Rust or learning Solana architecture. So my question to you is how to add Solana's liquidity and users to your EVM dApp. Have you ever tried doing that? I've talked to someone today who has actually attempted it, and I'm curious to know if he's here or if anybody else has ever tried it. By a show of hands? No, nobody tried it. Are you familiar with Solana architecture? Okay, and other people are from Ethereum. Okay, that's great. Then I'd like to present you how we are tackling this problem, adding Solana liquidity and user base to EVM dApps. And if you have other ideas, I'll be happy to hear them at the end. So by asking this question, we have created EVM, which is more than just EVM compatibility because it contains both Ethereum and Solana benefits. And of course, for EVM developers, the main benefit is that you don't have to learn Rust to switch to Solana, and you can stay within your EVM comfort zone using all the same tools that you're familiar with, hard hat, you can write in Solidity, you can connect with MetaMask, and use Ethereum RPCs. And you can add Solana benefits all at the same time. You can use its parallel execution, its low gas fees in your app, and access the growing Solana ecosystem with a huge user base. So what is EVM? How does it do all that? First of all, you might have thought that EVM has something to do with a bridge, but in fact, it couldn't be further from the truth. It's not a bridge or an L2. In fact, EVM is a Solana network extension. It's a program on Solana that lets you execute EVM bytecode within Solana runtime. And it does that by having two main components, Neon Proxy and Neon EVM program, and also by including different composability libraries and precompilers that abstract away Solana's architecture for EVM builders to incorporate into their Solidity caller contracts. So as I've started telling you, there are two pillars of Neon EVM, which are the Neon EVM program that lives on Solana and executes EVM bytecode, and Neon Proxy that prepares transactions off-chain and translates EVM logic into Solana constraints. So the transaction flow for both EVM users and Solana users would look like their native flows, the flows that they're used to, because an EVM user can connect to a dApp using a MetaMask wallet, and at the same time, a Solana user can connect to a dApp using the Solana wallet like Phantom. And each of them can use the functionality and connect to Solana programs and use Solana tokens by just connecting to your dApp and sending their transactions. And a Neon EVM user will send an Ethereum-like transaction, which will be, let me show you here. So they will send an Ethereum-like transaction, which will be translated in the Neon proxy with the help of the Neon libraries into a Solana transaction. So the EVM transaction will be included in the data field of a Solana transaction, and it will be sent to a Neon EVM program, a program on Solana, where, by the way, your smart contracts should be deployed in order to do all that. And it will execute the transactions so that you can use, for example, SPL tokens like USDC or Sol, or you can connect to Solana programs like Radium, Metaplex, or Jupyter, or other custom programs as well, with the help of the composability libraries that contain the architecture of Solana and these programs in them. So, and for Solana users, the whole experience will look like a native Solana experience because they will just send a Solana transaction and Neon EVM will add EVM bytecode to this Solana transaction when sending to Neon EVM program. And again, then the user will interact with Solana programs and Solana and SPL tokens. Now, how does Neon make sure Solana logic is triggered from Solidity contracts in the most seamless way possible, so that EVM developers don't have to suffer through the learning of Solana architecture? It's all in the works of composability feature. And composability feature by Neon EVM is constructed of libraries and precompiled contracts that allow the transactions to become atomic when sending to Solana, that ensure interoperability of tokens by introducing a new hybrid standard, ERC20 SPL, which is an ERC20 wrapper for SPL token, and by including instruction encoding within the libraries, so that when you import the libraries, you get the instruction generation in a way that Solana expects to get them. And also, all the account and state management is also abstracted away from the EVM developer, so that you don't need to understand what kind of accounts you need to make, how to save the balances, where the balances are stored. So everything is abstracted away by these libraries so that you don't need to even know what's going on there. Well, of course, it's better to know what's going on there, but I mean, you don't have to learn. Behind the scenes, composability consisting of the libraries and the precompiled contract starts from the caller contract that integrates, that imports composability libraries and sends the generated instructions to the precompiled contract, sends a direct call to execute the instructions to the precompiled contract, which does that on Solana. And again, if we zoom out a bit from the caller contracts, libraries, and precompiles, we see how composability and Solana native SDK allow both EVM and Solana users to interact with Solana programs. So we have two main entry points for the users. On the left, we have new EVM users or just EVM users who access Solana programs through the EVM wallets, and on the and on the right we have Solana users who access the same dApp, but through Solana native experience. Because when they request a dApp action, so for example, send a transaction, make a swap, the Solana native SDK created by Neon EVM gets this transaction and sends it to data account. It transforms this transaction to include EVM bytecode. And the Neon EVM operators that run Neon proxy get this transaction from the data account and send it back to Solana, so that Neon EVM can execute it on Solana natively and directly. And this hybrid architecture does something very powerful. It unifies developer and user experience across chains. dApp developers write standard Solidity contracts and deploy to Neon EVM, and then both EVM and Solana users can interact with the same logic with no separate deployments or bridges. It's not a sidechain, it's not a bridge, and it's not an L2. It's a Solana native runtime that unlocks full composability between Solana and Ethereum apps. Thank you so much for your attention. If you are looking to build something cross-chain or cross-runtime, we'll be happy to answer your questions and talk. Thank you. Any questions? Yes.
Hey, thank you for the presentation. I have a question related to the risks. Which risks, as I am as a developer, have while I will use like Neon VM comparing to like another L1 or L2 chain? Thank you.
Well, I will need to check with our auditors and security engineers because I'm not specifically working with the risks. But you should know that this is going to be slower. So you will need to accommodate that. And also, the integration isn't that simple. So it's great that you don't have to have 2 code bases that you need to maintain, but at the same time, to allow for this to integrate into your smart contracts, you will need to understand how to use the composability libraries and the precompiled contracts. Yeah, again, this is simpler still than learning a whole new ecosystem.